All right, so last lesson we talked about simple interest. Today we want to talk about another type of interest, which is called compound interest. So first, a definition. If at the end of a payment period, the interest due is reinvested at the same rate, then the interest as well as the original principal will earn interest during the next payment period. Interest paid on interest reinvested is called compound interest. So for each payment period, so for example, every year, at the end of that year, the interest is figured. The interest you earn gets added in with what the principal was. And then in the following year, when they figure the interest again, the interest will be figured on that new, slightly higher amount. Let me show you what I mean. So let's suppose you deposit $1,000 in a bank that pays 5% compounded annually. Okay, so let's just use some simple interest here to figure out what would be the first year. So A would equal the $1,000 times 1, plus the rate, which would be 0.05, times the time, which in this case is just 1 year, so we don't really need to put that. And if I actually work that out, I would be taking the 1,000 times a 1.05, which would end up giving me $1,050. So the amount in the account would be $1,050. And when we go to figure out the second year, that $1,050 now is my new principal. Okay? But instead of writing it as the $1,050 that I have here, I want to write it as this, because you're going to see a pattern here that's going to develop. So I'm going to use the 1,000 times 1.05, which is what got me this $1,050. And then I'm going to take that times another 1.05. So here's my new principal. Here is the rate that I'm still multiplying by, okay, because this is just for 1 more year, so it's still 5% and it's 1 more year. And if I simplify this, then what I'm looking at is 1,000 times 1.5, which was being multiplied twice. So I can give it an exponent of 2. Okay? Now, I'm not going to actually work out that answer right now, because what we're really more interested in at the moment is the pattern that's going to develop. Okay, so now let's go to a third year. So in the third year, my principal is going to again be what I ended up with at the end of the second year. So that's this amount that I ended up with. So the 1,000 times 1.05, this time to the second power. That is going to get multiplied by another 1.05. Okay, because again, it's just 1 more year, still going at a 5% rate, right? And so simplifying that would give me 1,000 times 1.05. But now I have 1, 2, 3 of these, so this would be to the third power. Okay, so notice the relationship here. For the first year, I just had 1.05 that I was multiplying by. In the second year, I now have 2 1.05s. In the third year, I'm now using 3 1.05s. And so I'm using this number here as the exponent here to show how many times we continue to take interest, put it back in, use that new amount in order to take the next interest for the next period. So if that's the case, then when I want to find the amount I would have after 10 years, what would I use for the exponent? Stop your video for just a second here and answer this on the side. What should we use for the exponent if we want to know how much money we would have at the end of 10 years? Well, hopefully you see the pattern and you realize that my equation would be A equals the 1,000, which is still the very starting amount that we had right here in the problem, but I would be taking the 1.5 now to the 10th power because this is the 10th year. So in general, our equation ends up being A equals 1,000 times 1.05 taken to the nth power. However many years I'm interested in, that is what I put in for the exponent. Okay? So that leads us then to the formula for compound interest when we are compounding annually. Now we'll expand this in class tomorrow and talk about compounding for other time periods, but for right now we just want to focus on compounding annually. So if we are compounding annually, then our general formula becomes A equals P times 1 plus R raised to the t power. So that t got moved from being in here with simple interest to now being out here as our exponent to represent the fact that we keep multiplying by that number. Now the A, the P, the R, and the T all still mean the same thing. A still gives us our amount, which we can also call the future value. P is still going to represent our principal, which we can also call the present value. The R is still the annual percentage rate. And the T is still going to represent the time in years. So the representation of A, P, R, and T is not different. It's just how we're using it that's a little bit different when we're dealing with compound interest. And if we look at the graph of what was happening in our situation, this is the graph of our 1,000 times 1.05 to the x power. Now I asked you in the last lesson what kind of graph our simple interest problem gave us. Now I'm going to ask you the same question now. Pause your video for just a moment and answer what kind of graph does this compound interest problem give us? Well, hopefully you remember from earlier this year that any graph that looks like this one is a type of exponential graph. Okay, which makes sense because now we do have time as one of our variables in an exponential spot. So it makes sense that we should be seeing an exponential graph. So just try one more problem here. Go ahead and try this on your own first. Pause your video, put in the answer that you think you would get as the amount in the account with this these parameters, and then come back and let's see if you got the right answer. All right, so if we are taking a deposit of $500, that will be our principal. We're using a percentage rate of 8%, so that will go in for R. And we want this to go for 10 years, so that's going to be our exponent t. And when you work that out in a calculator, your account would have $1,079 and about 46 cents. So in 10 years, your initial investment would more than double using 8% compounded annually. All right, so that should give you a pretty good introduction to the idea of compound interest. And as I said, we'll build on this in class by looking at compounding that happens at a different period of time than just annually. But until then, I hope this is something that will make sense and that you can let sink in a little bit, and we will build on this next class. And we'll see you then.